In this video, we're computing the integral of the sine of square root of x. And this is part of a whole class of integrals that looks sort of like this. We could have a cosine of square root of x, tangent square root of x, even e to the square root of x. And the trick to all of them is to start with a u substitution. We're going to let u equal square root of x. This means that du is going to be the derivative of square root of x times dx. Well, the square root of x has a derivative of 1 over 2 times the square root of x. And the nice thing about our u substitution is it simplified the argument of the sine function to a single thing. That's the sine of u. The problematic part is that we need to find a way to express dx in terms of du. So we start to work on that. And we'll just multiply both sides by 2 square root of x. And this is where the magic really happens for this trick. Now we remember that the square root of x was just u itself. So dx can be re-expressed as 2 times u times du. Now we make all the substitutions in our integral. Dx being replaced by 2 times u times du, and square root of x being replaced by u in that sine function. And now we have the integral of 2u sine u du. Now this is a classic integration by parts problem. And you might be used to using the notation of u and dv in our integration by parts, but u has already been used here, so we're going to have to choose something else. I'm just going to use s and t for these. So I start by letting s equal 2u. That means ds is just 2 du. And then dt is going to be the rest of the integral. That was the sine u du. And that means t itself is going to be the antiderivative of the sine function. Well, that's a negative cosine, so I have negative cosine of u. Now we apply the integration by parts formula, and we'll have an s times t, that's negative 2u cosine u, minus the integral of t ds. Well, t is carrying a minus sign with it, so we can bring that out in front of the integral, and we just end up with a plus sign. And then I have the integral of 2 cosine u. So that leading term is a spectator as we compute the integral. I have negative 2u cosine u, and then plus a 2 times the antiderivative of the cosine function, which is just the sine function. So I have sine u plus c. Now this integral isn't done because we still need to replace u back in terms of x. And u is just the square root of x, so I get negative 2 square root of x cosine of the square root of x plus 2 times the sine of the square root of x plus c, and that's it. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.